So now that we've shown how to stop a Java thread using a volatile Boolean or a volatile flag, let's talk about how to stop a Java thread by using an interrupt. And as we'll see, this is a bit more robust way of doing things. So a thread can be told to stop voluntarily by calling the thread's interrupt method. And what this does is this posts something known as an interrupt request to the thread, which says, excuse me, I would like you to interrupt yourself, please. And internally, these interrupts are implemented by a flag that's part of the Java thread state called interrupt status. Invoking thread interrupt sets this flag and says this thread has been interrupted. Programs, or rather the parts of the program that are running inside the thread, like things that are called from the run hook method, can check this flag a couple of different ways. One of is by using the interrupted method, which is a static method, which tests whether the current thread has been interrupted and has the side effect of resetting the interrupted flag. And the second method is interrupted. And this tests whether the thread has been interrupted, but doesn't reset the interrupted flag. So each of these approaches has pros and cons and side effects, and we'll talk about them in a moment. So here's a little program that we'll use to demonstrate this. This is a simple Java program that starts, runs, and interrupts a background thread. So you can see we make ourselves a new thread, and then we start it, and then we're going to go ahead and run concurrently for a while, and then when we get tired of doing that, we're going to interrupt it. Here's what this particular piece of code is going to do. It's going to run a little loop, which we implement as a Lambda expression passed into the constructor of thread, and it's going to basically iterate through the arguments passed to the program, and it'll do some blocking operations, and it'll do some non-blocking operations. And you'll see in a second why I differentiate between blocking and non-blocking operations. So after things have run for a while, we'll interrupt the thread, and then let's see what happens depending on whether we're doing blocking or non-blocking operations. Now, in both cases, we have to check stuff to see what's happening. But as we'll see, the checking is done in slightly different ways. Let's start out by taking a look at the process blocking code. So what this is going to do is it's going to make calls to methods that are part of the Java virtual machine, or it could also be the Java class library, things like sleep and wait, and maybe rantrant lock, or synchronized, or semaphore acquire, all those good things. And basically, these would be things like wait, join, sleep, or blocking I/O calls on so-called interrupted or interruptible channels. And we'll talk about what that means in just a bit. In all of those cases, because these are calling into sort of system libraries that don't know anything about volatile Boolean flags, they are programmed to detect when the interrupt status changes. And then they will throw the interrupted exception, as you can see here. So this will come back as an interrupted exception being thrown, which we can catch and do something with. And we'll talk about patterns of catching these exceptions later. Here's the process non-blocking call. Now, this one's the one that's going to be doing compute-bound operations. These are non-blocking calls. So they don't sleep, they don't wait, and so on. They don't join. Instead, they compute. And therefore, the way we check to see if the interrupt status flag has been set is we actually make a call to the thread.interrupted method. And this method is a static method that returns true if the calling thread has its interrupt status flag set. So if the thread has been interrupted, then we're going to throw the interrupted exception. Notice that this method has a side effect of clearing the interrupt status the first time it's called. So you call it once, it returns true or false, and it has the side effect of clearing that status flag. This particular example will also throw the interrupted exception, which is treated like a normal object up the stack of exception handling. You can see more about that here at this link. Another way of doing things is by using the isInterrupted method. And this is a non-static method that has to be called on a particular thread object. And so isInterrupted is going to return true if the designated thread has its interrupted status flag set. However, unlike the interrupted method, it can be called multiple times without affecting the interrupted status flag. So that flag will always be true, whereas with the interrupted method, it will be reset after the first call. All of these methods, like interrupt, interrupted, is interrupted, are all virtual, and you can all override them if you so desire. However, make sure you know what you're doing if you're going to do this. I sort of advise against it, although I've used that technique in my programs various points, but usually not a very good idea. So that's the end of the overview of how to stop a thread using interrupts. And as you can see, once again, it's still voluntary, but it's baked in more effectively into the underlying Java execution environment. So we don't have the problems that we saw before with the volatile flags.